Okay, in this lesson we're going to be talking about algebraic expressions and how to evaluate an expression when we substitute in a value for it. An algebraic expression is basically a math sentence, a math phrase made up of numbers and variables, like 2x plus 7. That is an algebraic expression. Okay, substitution property is one we're going to be using in this lesson. So if the algebraic definition says that if A equals B, then A may be replaced for B in any expression. This will make more sense when we see a few problems, okay? But to evaluate an expression, an algebraic expression, with variable replacements, we're going to substitute the variables with their given values. Each time you substitute a variable with a number, you want to put a parentheses around that number. Just trust me, it'll make it easier and less confusing. And then we're going to follow the order of operations. Seems like we just learned that, right, in the last lesson? We're going to follow the order of operations to evaluate, okay? So let's look at some examples. So evaluate each expression using the variable replacements. Question number 1, the algebraic expression says A times B to the second plus C. If A equals 2, B equals 4, C equals 7. So I'm going to take that expression and I'm going to substitute in these values for the letters, for the variables. Remember, substitute means something comes out and something else goes in its place. So for A equals 2, anywhere I see an A, I'm going to take the A out and I'm going to put a 2 in its place. So this expression would become, well, here's an A, I'm going to replace that with a 2, and I'm going to put parentheses around it. And then B to the second power, well, B is 4, so I'm going to put a 4 where B is at, plus C, and C is 7. And now if I want to evaluate that, that simply means tell me what the value is, simplify it until you get down to one number. I'm going to use the order of operations to do that. Well, I have multiplication here, 2 times 4, but I also have this exponent. And remember, the order of operations was PEMDAS. Okay, when it says parentheses, that means if there's any calculations to do inside the parentheses. And for these parentheses, there's not, because there's only one number. So there's really nothing to do in the parentheses, so that's done. Now I need to do the exponents, the 4 to the second power. Now remember, that does not mean 4 times 2. That means 4 twice. 4 times 4, which would be 16. So I've done my exponents. Now I'm going to do the multiplication and division. If there is any, and there is, this 2, remember a number next to a parentheses, whoops, I didn't put parentheses around it. Parentheses next to each other means multiplication. So 2 times 16 is 32 plus 7 would give me a final answer of 39. Okay. For number 2, this one says 3x to the second minus 4x if x equals negative 2. This means anywhere I see an x, even if it shows up more than once, I'm going to replace it with negative 2. So this becomes 3, and then the x gets replaced with negative 2 to the second minus 4 times negative 2. So notice all I've done is I've replaced the x's. Anywhere I see an x, I replaced it with negative 2 and I put it in parentheses. Following the rules of PEMDAS, the order of operations, there's no parentheses to do because these numbers are always down to one number. For this problem, they're down to one number. Exponents, negative 2 to the second power means negative 2 times negative 2. Not negative 2 times positive 2. Negative 2 twice. Negative 2 times negative 2 would be positive 4. I've done the exponents. Multiplication or division. There's multiplication. There's two multiplications from left to right. This multiplication, 3 times 4 would be 12 minus, and 4 times negative 2 would be negative 8. And I'm going to keep it in parentheses so that you can distinguish it from this negative sign, okay, or from that subtraction sign. So this subtraction sign I just brought down. So I've already used it, so I'm not going to use it again. 4 times negative 2 is negative 8. And remember, 12 minus negative 8, anytime you have two negatives right next to each other, that means they're one big positive, which turns into 12 plus 8, which would be 20. Okay? Okay, let's see what we got on the back of this to see if there's any other examples we can work. Yeah, let's go through a couple of these. Okay. This one says simplify each expression by combining like terms. Oops, there we go. Simplify each expression by combining like terms. So this is something that we need to take a minute to discuss. Like terms mean they have the same variable and the same exponent if there is an exponent. Okay? Like this one. 8y minus 9y. These have the same variable, so they are like terms. So I can combine those, and combine those simply means add or subtract them. Well, I can subtract them. 8y minus 9y, well, 8 minus 9 is negative 1y, or we could just write that as negative y. For number 2, 3x minus 7x. 3x and 7x are like terms, so I can add those together. 3x minus 7x is negative 4x. This 1 does not have an x in it, so it is not like those. So I cannot add that 1 into those. So that is my final answer. So when we're simplifying, what I like to say is do whatever you can do to a problem until you can't do anything else. And here, I can't do anything else, so I'm finished. It's simplified. So for number 3, if you think back to the commutative property, the commutative property lets me rearrange things and it won't change the outcome. So I could actually write this as 8a, then this positive a, then I can bring that minus 6 down and that minus 1 down, and I can see that, oh, I can add those together. 8a and a, remember that a by itself means there is just a 1 in front of it. So 8a and 1a would give me 9a. And I can also add these two together. Negative 6 minus 1 is negative 7. So my final answer would be 9a minus 7 because I cannot put these two together. I can't combine them. Those are not like terms. That has an a in it, and that doesn't. All right, let's look at one that's a little bit tougher. How about, number 10. 4xy and minus 6xy, those guys are like terms because they're the exact same variables, xy. But if you look at 5y, that one doesn't have an x in it, so it's not like those. And this 9x doesn't have a y in it, so it's not like those. So these two guys do not have any like terms that I can add in together, but I can add these two together. And 4xy, take away 6xy is negative 2xy. And the other ones I just have to bring down. Remember, simplify means do what you can until you can't do anything else. And guess what? I can't do anything else to that. So that is my answer. Okay. Let's look at, I don't know, how about 14? 6n squared and that 5n squared, those are like terms. 6n squared and 5n squared is 11n squared. This guy here has a like term right there. Now remember, the sign in front of that term belongs to that term. So that is a negative 2n and that is a negative 9n. Okay, remember subtraction signs, you treat them, yes, it is a subtraction sign, but a subtraction sign, you treat that term as a negative number. So even though there's a subtraction sign in front of it, I'm going to treat this as a negative 2n and treat this as a negative 9n. Negative 2 and negative 9 make negative 11n. Now, can I put those together? They have the same variable, but they don't have the same exponent. So no, I can't put those together. So those are going to have to stay like that. And then the only other thing I have this negative 3 and this negative 6. Those are both constants. They're numbers without variables, and I can put those together. And when I add negative 3 and negative 6, I get negative 9, and I can use a subtraction sign to show that that 9 is negative, just like I did with the 11n. I used a subtraction sign to show that's negative. So, okay, simplifying by combining like terms. Let's do one more real quick. Number 20, the perimeter. Remember, the perimeter just means the distance around the outside all added up. So this really means that I'm going to take this side, which is represented by 3y plus 5, and I'm going to add this side, which is represented by 6y, and I'm going to add this side, which is represented by y minus 4. And now I can simply add up all the like terms. Here's a 3y and a 6y and a y. That's that's 1y. So 3y and 6y and 1y make 10y. And then these constants here, 5 and negative 4, and when I add 5 and negative 4, I get positive 1. And if I add those together, I would get 11y, but wait, this doesn't have a y in it. That does. So these are not like terms. So for the perimeter, rather than coming up with one number, this is all I could do. This is the best I could do, which is 10y plus 1. So that's going to be the answer to that problem there. Okay. That's it for lesson 2. Good luck.